hand over to you.
Perfect, thank you, and hello everyone. It's great to be here tonight, and also really nice to see a lot of familiar faces. Melissa, right back at you here, so thanks for the shout out earlier. So welcome everyone to my presentation about discover a lightning fast way to debug in Salesforce with RFLIB. We've heard already there's a number of different people with different backgrounds here on the call, like including admins. While there's obviously some focus on during this presentation on the development side, I hope you will still find there's quite a bit of value for you as well. At the very least, you will find some tools as well for admins to kind of like get into the logging space and starting to annotate your customizations of the Salesforce platform, as well as it might be a good reason for you to ask, take this back and take it to your developer group and say like, look, there's something like this could really help us to operate better together and work right out of kind of like one domain as we're trying to debug our applications, and give basically them the link to take a look at the repository. So with no further ado, let's get started. Quick hello for myself. I mean, I introduced myself earlier a little bit. Just about my background, I've been in the Salesforce ecosystem for now way over 10 years, worked for ISVs as well as for consultants. I had like the pleasure of working in the niche area of CTI adapters at some point. So if you have any questions about that, feel free to ping me and ask me any questions you might have about that. But lately, like obviously been exploring the consulting space like for the last, how many is it, like 5-6 years, I guess, and enjoying that a lot. And I've been also like an open source contributor, which you will see today in the form of RFLIB, but that's not the only project that I've been working on. I did contribution to existing projects in the Salesforce space, but as well as like on JavaScript side and even in the Java domain in my past. Generally speaking, I highly recommend people to look out for opportunities to contribute to open source. Not only will you be able to give back to the community, but also it is a great opportunity just to learn new skills. One of the key drivers, to be honest, for RFLIB was also for me to play around with different areas of Salesforce that I didn't have much experience in and I wanted to explore further. So Lightning Web Components is one example. And then what you will see later, the latest edition around big objects was just another good reason to add a new feature. All right, so looking at this picture here, that was me like at the beginning of my career. Maybe not quite exactly the same face, but at least the same look, because as I started out my development career, that was before I got into the Salesforce ecosystem, I worked on CTI applications. So basically agent desktop applications or soft phones in Java and .NET. And I joined a product company and that company was building soft phones. They had already a product that's been around for like about 5 years, I think, at the time when I joined. And I don't know if you can imagine it, but when you think about agents managing phone calls in their browser, this is like a very event-driven type of application because a lot of the activities are not driven by the user, clicking through record data and such, but actually by someone calling into a contact center. So there's a lot of dynamic behavior that you have very little control over, and obviously like integration is involved with CRM systems and other ERP applications, and there's a lot happening, and that means also high complexity. A lot can go wrong. Unfortunately, the application that I joined did not have a sophisticated logging system in place. Like they had a logging library and there were some log statements, but whenever I was asked to deal with a support ticket, which as I started out like happened quite a bit, things became very difficult and very fast and frustrating, to be honest, because you're dealing with a premise application that sits in a network environment of your customers, and then you get like a vague problem description and then maybe some log files sent from the app server. And what the problem with that is then where do you even start, right? Like you're trying to then look at timing or other things to kind of dig yourself into what the application was doing at the time when the problem occurred and figuring out, like comparing it to the code base, like what went wrong, where did it take the wrong path? These things took days, sometimes even longer, in order to figure out, and required multiple interactions with the customers and trying to get more information, what the agent did, what was the call looking like, and so forth. And it was really, really frustrating and slowed us down, not just in development, like not just in support of the application, but also in the development side itself, as we were trying to build new features and running into new problems that we introduced because of it. So the good news was, though, that eventually we ended up building a new application right from scratch. Same software product, or like similar software product, but like an entire new build and a new architecture. The good news was that we put in like logging right from the get-go, and we took the experience and the pain from the past and converted that into action by making like logging a high priority in our development. But one of the new challenges that we had is that a lot of the application logic we moved into the JavaScript side between the applications. Before it was a little bit more server-side driven. Now it was like more than 50% of the business logic was sitting on the client side, and that made debugging even harder. So what we've done is we built out a custom logging framework on the JavaScript side that integrated into the backend and then created consolidated logs. What that allowed us to do is have like full visibility, not only what happened on the server side, but also what happened in the browser and how the two interacted with one another. This was a huge win, not only from a development perspective, like we had a lot more diagnostic information as we coded ourselves, but then when it came to supporting our app, like things got so much easier. It was a night and day experience. And just to give you one example, like on the capabilities of what that framework allowed us to do is we were able through our logs to actually prove to one of our customers that they had packet loss happening on the network switch during peak hours, because we could see on the server side, here's the message that we're sending to the client. And we knew on the client side, based on the logs, that it was never received. Just to give you a little bit of a picture. Obviously, that was a very influential experience, and I carried that forward pretty much in all the work I've done over the years, whether that was in the Salesforce system or outside of it. That like logging is such an essential piece of what you're doing that it has to be kind of like a first-class citizen of your application logic. Now, why is there a need for RFLIB? Coming back to Salesforce, so why do we need to build a logging framework? Because there are already some out there. Well, there's still a number of problems that needed to be solved. Number one, what I've seen, like especially throughout my consulting work, getting into different customer orgs, is there's a substantial number of Salesforce implementations that still don't even have the mindset of logging to begin with. So by building out a framework for it, I can also educate and really drive into this experience about why logging is important, which you're part of here today as with this presentation. I know even of companies that are removing system.debug statements from their code after they finish a feature because they believe that it's not good practice to keep it around. And I obviously have a very different opinion about that. Second reason is there's like lots of libraries are built in silos. And so you have a logging framework, you have trigger frameworks, they're all really great in what they're doing individually. But I wanted to build a more integrated experience because unfortunately, Salesforce doesn't make it too easy for us to adopt different types of packages and have them interact with one another through dependencies, etc. And so I wanted to create basically one stack of like tools or modules that are dependent on one another, and where logging is a first-class citizen that is really integrated. Next, like many of the logging libraries today are built for Apex, but reality is that with OnAura and LWC, we have a lot of the business logic moving into the front end, very similar to what we've done back in the day with the new softphone application. So now you're standing with the same problem, like you have the Lightning record service, Lightning data service, the Lightning data service that allows you to interact with the database even without a controller being in the picture. So if you have a component or multiple components that act like with one another through events and use the LDS in order to access data on the Salesforce side without any Apex code being involved, how do you get visibility into what's happening in those components, especially when something goes wrong? And last but not least, like there's the code focus of current libraries, and that is like obviously logging libraries are built for Apex, maybe even JavaScript, but then what about Flow? Process builder normally, though, like, I mean, with Salesforce recent announcements, like Flow is really the big tool here that is to mention. So we want to create the same experience in Flow that we want to have like in our other languages on the Salesforce platform, because, you know, the way I see it, Flow is just another programming language, and even so it's point and click. You know, those flows can get really complex, and you want to understand what path it took at the time when a problem occurred, not when you're running it through the debugger. So these were all reasons that kind of like motivated me to get started on building my own library. So what is RFLIB exactly? Well, it combines the experiences of the best practices that I learned over the years. And a lot of it was influenced by Dan Appleman's Advanced Epics Programming book.
Recording in progress.
Okay. And kind of combining that to create a library that helps you build out your customizations on the Salesforce platform and serves as a solid foundation of your org. I added the repository link at the bottom of the slide. I personally like to browse repositories as I listen to presentations, so feel free to do that. And if you have any questions of stuff that you see in the repo, please don't hesitate to bring them up at any time as well. Awesome. So RFLIB consists out of 3 core features and packages. Number 1 is the logging framework. The second one is a feature switches framework, as well as like a functionality, and the last is a trigger framework. Like each of those components is its individual package, and each depends on the predecessors. So the feature switch framework has a dependency on the logging framework, so you cannot run it without. And this trigger framework depends on both of the other 2 ones before. The reason why it was built that way is to create that integrated experience, because feature switches and trigger framework have logging built in, and doing that with the best practices in mind of the logging framework, so that you don't have to do these things anymore. Imagine you have 2 existing libraries from other people right now. If you wanted to combine them and get like the logging into your trigger framework, you can obviously modify the code, assuming that it's not a managed package. But then your upgrade path becomes a lot more difficult. So if someone adds new features and you want to adopt them from a code perspective, you need to make sure it doesn't override the changes that you've done on the library. And this is one of the pain points that I wanted to address with this architecture. All right. So what we're going to do now is we're going to take a step back. We're going to talk about logging in Salesforce in general first, before we then later on dive deeper into some of the features of what the framework comes with on its own. And so therefore, I wanted to share with you basically my philosophy about logging. The way I see logging, it's like an instrumentation of code. It's about making the code tell us a story about the execution context, whether that is like the transaction on the Salesforce side or like the session in the browser. The key of logging is to take code and explain it in English language, right? Or like whatever your native language is and you're using in your logs, but doing it in a human readable type of language that doesn't really require a lot of technical knowledge. You want to describe the state of your application during the execution, not just the stack trace itself, because that's something that the platform provides us with already when we see any kind of error messages, right? We have a stack trace about what methods it went through. But what we don't know is within those methods, did it enter this if statement or not, right? How many iterations did it go through in the loop that was there, and so on. And maybe it visited some functions on the path that it eventually then exited out of before hitting the error that is actually related to the problem that was causing the issue. So the logging is that part of the application that not only provides these details, but keeps track of the entire path that your code takes throughout the execution context. And that's the big value that it brings to it. Apex debug logs can do this today too, but most of the content in the debug logs is platform-specific log statements like method exit, query XYZ, and not focused on the business logic. And what I found from my experience over the years is that when you faced with a bug, when you're faced with a problem, you need to start on the 30,000 feet level view and then slowly make your way down into the weeds and more details, depending on where the problem lies. Sometimes, like looking at the business logic alone will help you to solve the problem and identify the root cause. Other days, you may actually need to go down all the way to the platform level and see exactly what was happening on the Salesforce platform in order to figure out why certain things weren't working the way they should. But the key is you always start like with a high level, because that's how you identify the smaller areas in the lower level logs to focus on, and instead of like, looking through 20 megabytes or more of Apex debug logs. And I was dealing with some issues in the last week, and I think I was dealing with log files that had like between 100 and 200,000 lines of code. So, like of messages, like from the Salesforce platform itself. Like, it's really hard to navigate your way through it and find that needle in the haystack there, right? So there is no right or wrong to logging. In my opinion, it's really just a bit of an art. And so when we look at the guiding principles of logging, I think what you're seeing here is on the right-hand side is some code from the demo project that you're going to see later in action as well. You can also find the source code on my GitHub repository as well. You will see the link in just a bit. And I'm so mixing here a couple of things where general guidance and like some specifics to RFLIBs. So one thing that is really important, as I just mentioned, you want the logs to kind of tell a story of where your code went and what the state of the application was as it was passing through. That means you need to cover as many code paths as possible. And you see that reflected here on the right-hand side, where we have like in the if statement, a log statement that says like, hey, we actually have a command here that we need to execute, right? There's a warning statement at the end, because ultimately we should hit this path here as a best case or a happy path scenario, and never really end up at the end here where we have to throw an exception. We have logging that is when an Apex error occurs, and so on, right? So it's really important to put in details as we're entering the method, and then what path it took within, in order to get the proper context information as we're looking at it, like from a historic point of view, as like we're debugging an issue. Something that is important for Salesforce in general is like there are resource constraints or governor limits everywhere, right? And the same applies like when it comes to logging. You need to be cautious about the resources that you're using, whether that is like heap space, CPU, DMLs, etc. Everything matters, and RFLIB is really heavily optimized to reduce its footprint. But part of it is also like what the developer does when they're writing their custom logic, and that means you need to reduce the number of log statements. Why? Because the way RFLIB works is that it has what is called a log stack, where I collect all the log statements and cache them so that I can reduce the number of messages and platform events that we send out when we notify about any kind of log events. And obviously that stack has a limit, which means that if you have more than 100 messages in it, it will start discarding the oldest messages as it adds new ones to it. And a message is defined literally by a single statement. So that's why you want to be a little bit more efficient and much rather go in and put more into a single message than to have like multiple logger statements one after another. I've seen that multiple times where developers say logger.info and then line 1, line 2, and then we repeat that logger.info, logger.info, etc. whereas all you need to do is chain the information that you want to print out in one single statement. And RFLIB has some nice ways of making that more convenient. As you can see here on the top, it has a placeholder syntax where you then put multiple variables just at the end, and you don't have to do ugly string concatenations. One thing that is often overlooked, and that just applies to RFLIB, but to any other language and logging in general, is like it's important to use the right log levels. Why is that important? Because you have configuration that is based on them, whether you want to have certain log levels to be logged into a file. In RFLIB's case, what do you report on, etc. So if you don't have a good practice around what level each message actually applies to, whether it's an info message, a warning, debug, and so on, that can really cause you grief, because then suddenly you don't have the means to abstract within the log messages as well. Because even within the business functionality, as you're putting in your logging, there are multiple abstraction layers, right? You kind of start first with kind of the info level and higher, like info, warning, error, and fatal. And then only when these are not good enough, you start expanding and looking at debug or other levels as well. And the reason for that is because it can get really, really noisy, and you might lose bigger picture information when you turn all debug levels, all logging levels on by default. So you want to like kind of tap into them only when you have a use case where the initial case does not solve your problem already. So it's kind of part of the escalation path of debug an issue where your first attempt was not successful because you don't have enough diagnostic information and you need to dig deeper, hence probably reproducing the problem, and that's when you start increasing the log levels for that reproduction. All right, so I hinted like there's a need for RFLIB because there are gaps in the market, and some of them I mentioned already, but like really what are some core features where I see RFLIB is different to other frameworks that are out there? And that by no means is any comment on that the frameworks that exist, like they're all fantastic, and there's actually like a lot of them that I got inspired by and adopted features in a similar way. But the beauty of innovation is that you take what exists, like the good things that exist today, and improve upon them to make them better. And here are the things that I believe that where I put a lot of effort into to add more features and functionality to make RFLIB attractive and provide more values to developers and admins alike. So as I mentioned earlier, we do have full support for logging in LWC and OnAura. And when I say this, I mean is you're logging in those platforms, but it's actually going to be reported on the server side. So it's not like you're using console statements in JavaScript. What happens is like the framework like keeps on getting the log stack running, monitors the log statements that are printed, and when it finds an event that is configured as being report worthy, it fires all the log statements over to the client side. And we'll see that later in our demo, like really beautifully on how you can get visibility in your client side code from the server side without having to go and needing any access to the browser of your users. Already mentioned there are custom actions for process builder and flow. The collection of log statement is the log stack. There are other frameworks that kind of like send each and every statement out as an individual platform event, but that is very inefficient when you look at platform events, especially when your organization uses them for business cases as well, right? I mean, the framework needs to consume some things, unfortunately. There's no other way to get around that on the Salesforce platform, but we're trying really to be most efficient with the way how we're utilizing the platform governor limits and to not collide with any kind of business logic. There's rich configuration through custom settings, meaning that you can like really define very detailed on what how you want the framework to behave, and obviously use custom settings hierarchical functionality to override that for individual users as you engage with them in one-on-one debug sessions, for instance. So while you increase or lower debug level for one user, the rest of your user base is still going to use the same log levels. Hence, the logs are not getting flooded with any kind of additional notification. Working in the public sector, obviously privacy information is very critical. So there is the ability to mask certain content of the log via regular expression, and all of that is done through configuration. And then one of the key features is the 24/7 aspect. Like by using the framework, you have logging all the time. Apex debugs logs you turn on after the fact, right? There is a problem, there's no debug log running usually at the time. So you need to go in and say, hey, I'm going to enable logs for you, user ABC. And then you ask, like, can you please try to reproduce it? RFLIB keeps on monitoring ongoingly as the application runs. And then as it finds any kind of issues, notifies those ones. And we'll get into the details about what notifications aspects you have as well, like as part of the demo. And then there's new, like with the 3.0 release, the log archive. I'm using RFLIB more and more myself in my projects, and as well as talking to other developers in the market that are using the library. I came across a few governor limits and limitations around platform events as far as like the display goes, the actual showing of the platform events, that required us to create a more long-term solution from an archiving aspect and from a retention aspect for the log events, so that you can go back for longer periods of time, and you're not limited by the platform events for reading or consuming platform events, the limits to view them in the dashboard. And that's what the archive all is about. And then there's a ton of like utility classes as well. One of them is the log timer, which is a simple class that when applied right allows you to track timing between execution points within your class. So for instance, if you have an integration, a web request call out from Apex to external service, you can say like normally those requests should return within 1 or 2 seconds. So you can say like, hey, I'm adding a log timer around the call out, and say like, if there's a threshold of 3 seconds exceeded, I want to know when that happens. So what happens is like any web request that takes 2 seconds or less is just going to go by and the log timer completes and it's all good. But if it exceeds the threshold, what it will do is it will log a warning statement that you defined, and then normally those are being reported on. And as a result, you will see the notifications and can find out when there are performance segregations within your application. So lots of little goodies there, and I think there's some of them resonated with your personal needs as well. All right, I mentioned already there's like a large number of log statements. This is already a somewhat outdated screenshots. There are more settings now available today that users can go through. The key parts that I wanted to highlight is that many of the settings are based on log levels. So you define really detailed on what you what log statements you want to see in what capacity. And you have like the client and server side log stack sizes that you can configure. But the real thing that I really want to point out is like the log timer class and logger factory class settings here. What that does, it uses dependency injection, and dependency injection, for those that are not familiar with it, allows you to be to easily override functionality within the framework itself. What does that mean? It means that while RFLIB is a full-fledged framework coming out of the box that you can use, I understand that down the road, maybe 2 years from now, whatever, there might be something else that is better in logging than RFLIB. Maybe Salesforce comes out with their own logger class. That's all great. But then do you have to go in and replace all the log statements that you created in your customizations like over the years? No, you don't. And the reason for that is that you can use the interface that comes within the library and implement your own logger implementation with all the methods like info and so on, and then use whatever other service or methodology you want to apply to your logging, and then change the strings here to use your own class. And then whenever any code runs, it will use your class instead of the default like class that comes, the default logger that comes with a package. So this allows you to easily replace it without having to go into all your code and do heavy refactoring later on. continue to use the interface and the stability that it brings, but you'll feel free to change the implementations at any time. All right. So when it comes to using RFLIB in code, and we see now the same code again that we handled earlier today, and that we saw in one of the earlier slides. What you typically do is you declare a logger instance on the top of your class. You're using the logger util.getFactory, which uses those custom settings in order to determine what class it should actually generate, and then goes in to create a logger instance where you give it a context name. And these context names are really important because you can filter by them later on in the dashboard when we take a look. Then you follow the best practices from logging, which we already talked about. You do see here an example of the log timer as well, where we created one as we started invocation here. And we say like, okay, we should get through this execution of the command within 300 milliseconds. And then in the finally block here at the bottom, we call the done method, which then evaluates whether the duration between those two execution points was more or less than 300 milliseconds apart. And if it was above, then it takes this and logs a message, excuse me, that includes the string that you provided here, but also like how long it actually took to like go through the code between those two points. We already talked about like log generously. I highly recommend when it comes to controllers, like to any kind of like epics or epics controllers, either for Aura or for Visualforce, to use the try finally logic to properly handle any kind of exceptions, catch them. Feel free to rethrow them, but at least make sure that you have the logging for those ones. And this is like the first entry point on the server side. So this is kind of like your root class or root function. You want to make sure that anything is being caught here so that whenever it bubbles through higher classes, because they don't have try catch in place, that you get it at least before you return any response back to the client. That's how you're actually the most efficient with the logging framework in place. Now on the Aura side, what you do in your Aura component is you embed this logger component in there. By convention, I would recommend it always to use the Aura ID logger, but feel free to change it if you prefer. Then you give it a context name, the same how we saw it in Apex, and then something specific to Aura is whether you want to append the Aura component ID to it. So if it's set to true, the component ID will be added to the context name. And if you have a component placed in your page multiple times, because it's like a card that displays, like is being displayed for different type of records or something like that, then you have a way to distinguish between those in your log files, which can be really, really handy. Same like in Apex, you have like so let's start as like in your controller or helper functions, the first method call should then always be to find your logger component and get the instance of it. And then you can start logging. You can use messages with a placeholder syntax. We've seen this in Apex already. The same applies here in JavaScript. And then again, log generously, like we said before, and make sure that you're using the right log levels. In LWC, obviously, we're dealing with a little bit of a different infrastructure here and environment architecture. So you got to import the factory function from the RFLIB logger module. Then you invoke the factory function with a context name to create your local logger instance, and then you use that in your code. Similarly, you do have the placeholder syntax. However, when we compare it to Aura, here you needed to wrap all the different arguments like that need to be replaced into a list. In LWC, you don't have to do that anymore. You simply just chain any arguments together, and you can use as many as you want to. If you have like 3 placeholders here, then you go like and have 3 additional arguments after the initial log message string that is being put in as a mandatory parameter. Okay, and then last but not least, logging is all great, but it's only good if you can actually have access to the logs, and that's where the log monitor comes into the picture. So you can use this to view your logs in real time as they're being generated. They will pop up here, and if you're using the real-time modes. And you can look at them historically, either through replaying all the events that have recently been published. And when I say recently, it's the last 72 hours. That's how long a platform event is being held by Salesforce for review. And then you can then filter on it. You see here on the right-hand side that user IDs, which are listed in the list view, are actually being resolved on the right-hand side. And you have different connection modes that allow you to switch and say like, okay, I want real-time view right now, or I want to hit the archive, and we'll see all of that in the demo. All right. Now, before I start with the demo, are there any questions? I'm just going to look here through the chat. Anything in here? No? Awesome. I'll just take a sip. And we'll go on. All right. So in this demo, we'll cover three different, like two scenarios. And then one is a DML issue, where we have like an error while trying to perform the DML operation. The second issue is a data inconsistency scenario without an error in your client-side code on the OnAura side. And then today, last, we're going to actually take a closer look at the Op Center and the features and what it provides you, including a feature called Permission Explorer that I haven't mentioned yet, that can come in pretty handy as well. So quick look here. I'm in my demo org. I have on one side here the log monitor, and then what we really be operating in is the Dreamhouse sample application that Salesforce provides. So I'm not sure if you're familiar with it, but it's basically a set of like OnAura components, and they have a Lightning Web component version as well, and other tools like just to show you how to code on the platform, best practices, and so forth. And when you start like a Scratch org with the Dreamhouse app installed, that's all great, but it doesn't come with any data. But they do have the sample data import here. So let's kind of start filling our application with life. But what we're going to see here in a second is that our data import failed. Now, why is that? Well, I created a validation rule that basically said that you cannot insert any properties that are older than 15 days, because kind of like when you think about the application in runtime, this is an invalid scenario, but we're dealing with the data load here right now. So obviously you might be inserting or modifying historic records. Coming back to the log monitor dashboard, what we see now is, hey, there's a message that was published. So let's take a look at this one. It already shows that there's a level of fatal, that there was something that completely crashed, and the context is the sample data controller, which seems related to the problem that we were just seeing on the screen. Now here on the right-hand side, I see then the stack of all the log messages that were collected as part of the transaction. As I'm scrolling down, so we can see here on the top that the import sample data function in the sample controller was invoked. And then we see it try to delete the bot command records, properties, and so forth, started importing different data sets. And then when we scroll down at the bottom, that's usually where the trouble lies. We see it failed to import the sample data, and we have a custom field validation error that your property is too old to be listed. So that gives us a really good hint already about what was going on in the application. We see the entire history of it, right? As we were going down and imported then the records, we also notice here that our triggers were involved, right? We have an init property date listed handler that is being invoked. So there's a trigger handler that runs and has like a certain functionalities to perform. And all of this is in the same context. If we had a flow that was executing or process builder, it would actually show in this log as well, alongside with your code log. So it all combines these things together because it runs in the same execution context. Now, if we're looking at this validation rule and looking at it here, we can see, hey, look, there is a feature switch involved. So we have this feature switch called data load in progress, and if it's not turned on, then obviously throw the exception. But if we go in and turn it on, then it actually won't fire this validation rule anymore. So what we're going to do now is go to custom metadata and then look for our feature switches. Right here, go to manage records, edit the data load in progress, and just simply turn it on and set it as a flag here. Now we go back to our application and the data load succeeds. Perfect. So what we've seen here is like how there was a DML error that was immediately posted to the RFLIB log dashboard, and how feature switches in this case were used as part of a validation rule that allowed you to easily deactivate the validation rules. So this is like one of the advantages of feature switches. You can not only use them in the code, and there's a lot of utility classes that help to make this very easy, but also you can use them in your declarative tools. There are some limitations to it, but still a very powerful tool altogether. That was scenario one. Now that we have the data in, we can drive into scenario two, and that is actually our property finder. So when we go in here, as you can see, there's a list of properties that have been loaded now, and we have a search filter here on the right-hand side. Okay, and what happens is like I'm Johannes. I'm now not presenting here, but actually the user of our DreamHouse app, and I want to try to find like a property that has 3 bedrooms, a minimum of 3 bedrooms, and a minimum of 4 bathrooms, right? All right, perfect. But now when I'm looking at the results, I'm actually starting to notice that, you know, the filter that I applied is actually not properly reflected in the data that is being displayed here. Because if you're looking at this property here, there's only 3 baths in this house, but I wanted to have a minimum of 4. So why is that the case? So what I'm going to do is I'm going to obviously open up the ticket with my support staff, IT help desk, and say like, look, the results are not great. What can we do about it? So in this situation, coming back to the log monitors, there's no exceptions, no errors that have been pumped. There's just like a bad behavior of the application. So how are we going to how are we going to go about this? Well, this is where the custom settings comes into the picture. So what we would do for this particular user with changing the log levels. In this case, this is a complicated issue. We need to engage with the user. But the good news is we can do that from the comfort of our home without having necessarily a screen sharing session going or requiring access to the user's desktop itself. All we're going to do is in this case, would probably create a record for this user here to override it. But since it's all me, I'm going to just override the global log levels. And we are setting the client server log level here to info. And while we're at it, in production, obviously, we do not show any console logs. But like because this is a development org or like a demo org, I have the debug client console debug logging on by default. So I'm going to type in none here just to demonstrate also like how the settings are being applied like to the client side. So I made a couple changes. I'm going to save it here. Go back to this, and before I start refreshing my page, what you will see is right now when I open it up, there's a lot of console logs that were being printed by the application. So that was because the log level before I changed it was set to debug. Now I'm going to go in and start refreshing the page. But before I do that, I'm going to actually split up the pages so that you can see them side by side and see a little bit some of the magic happening in action. So now my new settings, as I refresh the page, my new settings are taking effect. And you can see on the right-hand side here, by just loading the page, how there are 14 logs that were created. And that's because we changed the log level on the client side, the reporting log level, from warning down to info. Now, every info statement is going to be reported over to the server. And we can see that we have like multiple statements reported from different components, right? Each component is typically a context. My recommendation is always to use class name or component names for the context itself, so you immediately know where to go to. And then they were all being printed onto this page, right? And if I look here, for instance, there's like the information that were before collected in the console. They are now all available on the clients on the server side. So you don't have to go back here and take a look at your printout, because eventually you don't see anything here anymore. Since we switched it to none, you have one log statement that was created before the logger configuration was retrieved, but after that, nothing is printed, which is what you want from a production application, right? So that people can see what's going on, especially for communities. That's really important. All right. So now that we have logging in place, we ask our user and say, like, can you please reproduce the problem? And he goes in and says, like, okay, I'm going to set this to 3 bedrooms and 4 bathrooms. I'm still getting the wrong results, but now we have like log statements that we can go about. So because we know that the user is dealing with the log filter, we start then looking at the latest logs that were being printed and diagnose a little bit of what was being listed, right? And one of the things that we eventually find out is, as we're looking towards the last few statements, that, hey, there was a fire filter change event that happened here. But what was happening is that the number of bedrooms was set to 3, the number of bathrooms was set to 4. But when we look at the get properties function that was being executed, which is the request to the server side, we're seeing that the number of bedrooms that were listed are now 4, and the number of bathrooms that were listed are now 3. Obviously, that doesn't make sense. So we have now proof from the client side that there seems something to have gone wrong in the code, how it translated the event into the actual controller call to do the search. Now, the good news is, like, then the next good news is when you have these log statements, right? Even if your code is minimized, which happens on the Salesforce platform, right? It compresses all the JavaScript code and minifies it. The log statements themselves are never going to be minimized. And that means that independent of what the code looks like in real and in JavaScript, like you always have these pieces as a kind of a navigation anchor in order to search. So when I go in now to my Visual Studio Code and take part of the log string that I know is static and start searching for it, it will actually find the statement that printed that particular message. And if I go in here and I say, like, okay, I know that we printed out the action parameters here, which is the list that I looked at, and that was wrong. So I'm going to start looking what those numbers were set to. And if I'm seeing here, there's a mix-up where, like, the number of bedrooms were not set to the number of bathrooms, but to the number of bedrooms and vice versa. So there was a coding mistake that did not cause any errors, could have been caught in testing, but it didn't, made it into production and caused like misbehavior of the application. And because of the logging framework, we now had a very efficient way of figuring this out and getting right to the point of the application of where the problem lies. Now that we made the change, we're just waiting for the push to the org to happen. And then we'll validate if our application and the issue is actually fixed. It's just going to take a few seconds here. Perfect. Oops, done. So I need to push with override. That usually happens when I set up the org in the mornings. I will just give it another few seconds. All right, now the change took effect, and we are going to minimize the dashboard again and refresh this page. starting, let's make this full screen to make it look better. And then we go here, do 3 bathrooms, 3 bedrooms, 4 bathrooms. And now we see that we always have every listing a minimum of 4 bathrooms and no false listings are being shown anymore. So I hope this shows like the power of the framework, that when you have these things in place in production, right, you don't have to be afraid anymore if problems are happening, because you have the power to support yourself in the debugging efforts by putting in the right log messages at the time of development that then later on help you to tackle any kind of like curveball that users or customers may be throwing at you. So that concludes scenario number 2. And now let's take another look at the log monitor and the op center in general, because there's a lot of work that went into just this piece once the logging was there, and make it very efficient. As I mentioned before, like everything in here is searchable, right? So yes, you're collecting logs, and this can sometimes go into the hundreds or thousands. It's optimized to easily navigate around by actually like using the search functionality in here to filter out different log statements. So you can see that obviously all of these ones have title list or title errors in it. Because of the log stack, lots of those messages are including actually the same content, right? As you can see here, like it all matches. Like there's sometimes different things that slightly change, but there's a lot of data that is being duplicated. But let's just say like we want to find, okay, all the statements where the number of bedrooms is 3. Let's do this a little bit more specific and see if it kind of filters them down. Now we're getting down to 20 messages, right? That are a lot more targeted instead of the 41. So then we can start navigating around through. This can be really powerful, especially when you look for searching for different users. That's a simple filter to get the user ID down and only look at one particular person. We also know that, okay, our log property filter was involved, so why we're not searching for that? We could then just go in and where we have the property filter list, title list, property filter right here, and use this statement in here, and now we only have property filters being listed. You see how instances, and that's one of the real great performance examples from Lightning Web Components as well. It is so unbelievably fast. It's like amazing, absolutely amazing. Like the performance of the tool, considering the amount of data that it sometimes has to process. You can always clear your logs here, which doesn't really delete them, it just removes them from the screen. You can always come back and say like, okay, I want to see all historic messages. And then it goes in and tries to replay everything that was produced like within the last 72 hours. And then you can start your filtering and searching in the same fashion again. As you see, the filter is still active and immediately applied to the events as they're coming in. And if I remove it, I get all the log messages back. If you know the operations are pretty noisy in production and you just want to say like, okay, I have the log segments that I want, I don't need any more additional noise, just disconnect here, and then basically like no new messages will come in. And last but not least, we have the archive, and that again is a new feature. Here you will see the messages that are being produced on the same day and met the log archive threshold. So let's go a quick look here back to the custom settings. We see here there's an archive log level, and that is set to warning. It was earlier set to info as well. Like when, depending on when the statements are being created, that's going to be the one item. Oops, where did I go? That defines of what actually goes into the archive. By default, it will go in and display the messages of the current day. So it will basically take 12 o'clock of the day that you're at and then start displaying these ones. But then you can also go in and start like filtering by specific dates, because obviously you can go back in time quite a bit. And if you're familiar with big objects in Salesforce, it by default allows you to store up to 1 million records. They are not being deleted, so you can pick up quite a few records over time if you don't perform any maintenance on it. So I'm going back here and say like, I want to look for the log events between the 1st of November and 8th, and I query. I see, hey, I did one test run of this org on the 5th when I initially set it up, and I just basically ran the sample data input dashboard, and you can find those once again. It supports all the same searching functionality, right? But it can process a lot of records. The one limitation there is in the dashboard, you can only look at 50,000 records at a time. That's a Salesforce query limit. And that's where the power of the timing comes in, where you need to know how you narrow it down from your time perspective. If you have like more records to display for whatever reason, then use this to kind of like minimize and search for the smallest amount of time that you have to capture the log events in. And last but not least, like in order to delete the archive, you can go in and use this delete button here. Again, this will also delete 50,000 records at a time from the oldest on. In this case, obviously, I have like not even 100. So it will basically wipe the entire thing, go clearing here. Right now, obviously, it doesn't refresh the screen. But if I go back and start querying, it should have deleted it. And that's a bug. So I have to take a look at that. These should have been gone. It's possible that it could be permission related. But that's kind of like the context of the functionality. On the other side here, there is the Permission Explorer. And basically what that does is allows you to review all the permissions that are in the work. That includes object permissions, field permissions, and that by profile or permission set. And as you can see, there's actually larger like number of records that you're now dealing with. Like I'm just trying to see what is a good example. You will download them all in one go, and then you use the same UI that you're familiar with from the dashboard in order to start searching and filtering things down. This is really powerful when you kind of try to figure out why possibly a user does not have access to a certain record or field, why they're not seeing it and doing that in a very fast way. And you see here now we're dealing with 25,000 records. But if I'm saying here, for instance, object is log event and search, okay, there's no permissions on the profiles that deal with a log event. But what happens if I switch to permission sets and do the same search again? If not, I'll take the account or the object. And permission sets don't have any records in the accounts. So, oops, I need to do this. Here you go. Let's try. Nope, nothing in here, right? But if you look here for, let's take the bot command, for example, simple way of filtering things down on the different parts and then kind of compare between permission sets and profiles, for instance, okay, who has actually access to these things. So I used it in several moments as well, like to kind of like debug kind of user permissions, especially around permission sets a lot. You can also export them into CSV really fast. So if you want your 25,000 records in CSV for further processing, this is a really quick way of actually getting them out of your system. That's it. Really happy to get feature requests for these tools, like, and see what can be done to improve them and make them better for you guys. So please let me know if you're using RFLIB, if there's anything that you desire. That would be very much appreciated. We're coming to the home stretch. So from here, it's going to get a lot faster. Just the last 10 minutes, quickly looking at feature switches and the trigger framework. On the feature switches, what we're dealing with is obviously support for custom metadata-based configuration. I like the aspect of custom metadata because it can be deployed. But what is not so great is that you're losing the hierarchical feature of custom settings. So I just built into the custom metadata in. So when you're dealing with feature switches in code and in flow, what happens is that you actually have the ability to create hierarchies where you have global settings, settings by profiles, settings by public groups, and by individual users if you need to. And the public group part is important because now you can do really nice A/B testing of features where you just deploy them to production, the feature switches off, but then you create an override on a public group level that you then assign different users to kind of run maybe new functionality, just to give an example. As I mentioned, you have API support for Apex, OnAura, LWC. There are utilities for each of those flavors. and they support those hierarchical features, whereas like when you access the CMTs through formulas, the hierarchical feature is not supported. That's just something to keep in mind. So you typically want to go for the global records in that case. Here's just some screenshots on how you use the feature in the various different tools and languages. So like hit me up any questions, or you can look at the recording in more details. For example, there's plenty of code in the sample repositories, and there's samples in the wiki as well on my repo. So there should be a lot of good information there to get you started. Now the trigger framework, looking at that one, it uses all the best practices for triggers. So every real trigger is a one-liner, basically, from now on. The handlers are all being configured in custom metadata, and it instantiates those ones dynamically, which means they really decouple from one another. That simplifies unit testing a lot, because you can go in and test your trigger handlers even sometimes without performing DML operations. You can just completely fake out the abstraction, which is good, because if you always have to do DMLs, you often run into regression issues when new validation rules are introduced and so forth, and you can avoid that for the stability of your unit tests. Then on top of that, logging is included, as I said, right out of the gate. And everything is inspired, again, by Dan Appelsman's book for advanced APIX programming, and it focuses on the order of the execution. So that's one thing that it tracks really nicely through the interfaces. Here we see an example of the configuration of a handler. This is like an email handler I used in the past at the beginning of RFLIB to send out email notifications for certain log messages, which you can configure as well. The one thing I do want to point out here is the exception behavior. You can say whether an error caught for the trigger execution, so an exception thrown in Apex that bubbles to the framework, will actually abort the transaction, or if you want to continue. If you have three trigger handlers that are atomic, meaning that they all perform individual tasks that don't depend on one another, why not execute 1 and 3 even if the second one fails? That way you only have to then fix possibly the data of the second trigger in order to do that. Just 1 second here. And Google is telling me that it's done. I should be stopping to work now. All right, next step. As I mentioned, like all the triggers are fully discovered. Oops, we're 1 step ahead here. Wonderful. So these were kind of like the advantages from a trigger framework perspective. What I want to finish up off with is basically a couple of stories that shows the potential of the logging framework. There are 2 stories from my past. Like one was a big CRM transformation project where we migrated a customer and all of the 600 users from a legacy CRM up to Salesforce. So go live was obviously like the traditional Friday, everyone turns off their computers with the old CRM, and Monday mornings they're coming back and starting to sign into Salesforce. Needless to say that like project was tight deadlines, and we were rushing, like we were working hard in order to make the go live date. Things were not like without problems as we started out, but because we had logging in, especially on the integration side, we were able to detect and group 200 errors on the first day into less than 10 categories. So we had over 200 error messages that were notified by the framework. And then based on the log statements, we were able to categorize them into 10 different types of issues. And within the next 48 hours, so from Monday through Wednesday, we were able to obviously put out some patches and fixes and deploy them into production to reduce them to less than 50 errors. And most of them were related to bad data. And we could identify that. So just this turnaround time was a huge gain of confidence in our customer, like in our client, that our solution was not perfect, but at least built with like operational stability in mind and enabling them to also then figure out like future problems, especially when it comes to data. The second example is like the full development cycle, where we were building customizations on a Lightning community. And it was very heavily customized and front-end driven. And we used OnAura components and a lot of force record data tags to interact with the Salesforce server side. What we actually found during load testing is that there was a race condition between force record data as we were executing two different changes to a record and try to save them, where the second change was coming before the first, and then eventually wiping out some of the data on the server side. And the reason why we were able to find that very quickly during load testing as well, because that was the only time when this scenario occurred, was through the logging framework. We were able to identify, similar to the example that we had here, that the requests were being made with different payloads in the right order, but they must have come to Salesforce in the wrong order based on field history. When it came to development efforts, like our developers were pushing to UAT ongoingly because we're using agile methodologies, and there was integration testing happening in UAT. And again, there were often issues that were based on bad testing data. And what happened is, like, those bad test data would create an error, there would be a notification, and it was set up to send out an email to my account. So whenever they were testing and had those problems, I already had an email in my inbox that was telling me exactly what the exception was, stack trace, and I saw the full log. And when then the tester came and said, hey, the integration isn't working again, I was able to go and tell him right away, hey, have you looked at your data here? I think there's something wrong. So what normally took 30 minutes of time because I had to go in, deactivate logging, ask him to reproduce the test, or go investigate the records and check the data first, was taking less than 5 minutes now because I already knew what the problem was before someone actually reached out to me. And needless to say that with the logging in place, when we went into production, we found yet another bare inbound integration issue just based on the test data, and we're able to action on it very, very quickly. I talked a lot, and thank you so much all for your patience. If I want to point out like 3 key benefits of the framework as a whole, it's that it creates faster development. It allows you to move your embed logging into your source code, and it helps you to debug it faster as a developer and support your UAT testing better. Hence, like, you're getting quicker through your stores and getting them ready for production. You have faster pod support. No more having to coordinate meetings, asking for reproduction because Apex logs were not turned on. You can jump right into the action before the client even or the user even reports that there was a problem. And you have more control because everything is so heavily driven by configuration. You can go in and make sure that you tune the framework to exactly your needs. As I mentioned, RFLIB 3.0 was released. I usually try to create a new version for every community talk that I give. So I was rushing on that big feature, and we saw there was a bug, so I'll take a look into that. Expect 3.01 to be coming out then in the near future. Here you have all the installation links that will get you right away to the package installation. One important thing to note is, like, RFLIB is packaged as a developer-controlled package or an unlocked package. That means you, yes, install it via the standard Salesforce package installation methods, but you will always have full access to the source code, meaning that you will see all the classes. Nothing is locked down the way it is with managed package. You can change it. You can take some of the classes out or some of the OnAura components, make modifications to them, and then have them in your source control, and they will always override what the package produces. It's really just a different form of, like, getting the metadata into your org if you don't want to work with a repository and embed it into your own local structure. And with that, I want to thank you all. I thank you all very much for listening. One thing that I want you to walk away with: logging is important, independent of what framework you're using. I think it's critical, like, to have it as in your mind whenever you work in Salesforce and customize, whether that is for the declarative side or for the coding side of things. And other than that, open for any questions. Thank you.
Fantastic.
Thank you, Chitendra.
If anybody have any question, feel free to unmute yourself and ask a question directly. And
yeah, I had a question. few of the questions we have posted in the chat, Amit. If Johan can go and just see if he can answer them.
Yeah, let's start with the chat quick. Let's see, Melissa, right? Can you show how you would create a custom log tracker for a specific person as opposed to changing the global custom settings? Absolutely can. You guys can still see my screen, right? As you have here the settings that are on a global level, and I'm just for the purpose of making it right, demonstrate on how this should be set up. Oops, it should be set up properly. So we have the client server logging of 1. This is set to none. Perfect, right? Now, as I'm going to start working with someone directly, I'm going to go in and say like, okay, either I have a user group that has issues, a profile, but more commonly, you're dealing with individual users that you're interacting with. Then you go in and create an override here that you say like, okay, I want to create a new configuration for, in this case, I only have one user account, my scratch org, but you would select the user of your choice and then start going in and say, okay, I don't want like this person to log to the archive. I'm dealing with it in real time. I'm going to change the client console logging to debug, which is good. And the email log level stays done, but this is the client server log level is going to set to info like we've done it in the project before. And we're doing the same for the log event reporting level on the server side. We're setting both of them to info. So this particular user will trigger events to show up in the dashboard whenever there's an info statement logged. Only this person. Everyone else, and you see it in the configuration now, and then you go back to the list. Everyone else will use the global settings. Only this user will use the specific versions that, the specific configuration that you chose. Is that what you were looking for?
Yes, thank you.
Perfect. And then your second question was, how do you set up logger statements in flows? I'm going to go quickly back to the presentation for that. And do I have a screenshot for that?
While you're headed back there, just so you know, there are multiple questions before mine that are very relevant questions. So after you finish this, make sure you scroll up.
Yep, will do. Thank you. So the way you're doing it in Flow, you're seeing here there's an Apex action, a Apex legacy action that for feature switches is called get my switch value, right? And there's one for logging as well. So you use this, actually, yeah, here, there's a log statement here. There's this action here that says log my switch turned off. That's a custom action that you can drag into your flow. And then you define the same parameters that you saw in the code. So there's a context that you put in. I normally put in the name of my flow. Then you can put in like a message as well. For messages, it can sometimes be a simple string. Or what I've also done for a more complex printout of variables, I created specific formulas in the flows that I then, like string formulas that I then use in the when I print out a log message.
So I guess I'm well versed in coding, but have only within the last year started exploring flows and doing stuff. And I've done some stuff, but I've never used an Apex action, or especially a legacy Apex action or a lightning action in a flow. I guess what I'm looking for, and obviously you don't have it right here, but I'm looking for more specific inside those nodes, the one that looks like a plug and the lightning one there, like what actually needs to be set up and how you would set it up. That's a side thought that you obviously don't have ready, but that's what I was really looking for.
Yeah, I can add it to my list, and then I'm not sure how quickly I can get it done, but before the end of the year, add it to the wiki.
Cool.
That's not a problem with screenshots and stuff like that.
Excellent.
Not a problem.
Thank you.
Mm-hmm. So I'm going up the list. So Praveen asked if there are any limitations for logs to get stored in custom objects. Will the logs get deleted after 30 days via batch ethics? So out of the box, RFLIB does not log to custom objects. It only creates platform events that are being consumable by the dashboard. Where is it? Let's bring it back. And merge the tabs here, right? So these are platform Let's see if we place them back. Yeah, these are platform events, right? The log archive is using big objects. So that is also not using custom objects, because I believe strongly big objects are better suited for that type of data to begin with. And also because custom objects, they are counting towards your standard Salesforce storage, and that can be adding a lot of records very quickly if you make mistakes from a logging perspective and things get out of control. Like literally, you can get thousands of records in minutes, and if you don't turn it off, like that can go on forever. Having said that, you can log to custom objects by using standard Salesforce functionality, for instance, a flow, to listen to the log to the platform event, and then record maybe only your fatal statements in a custom object so that you can use features such as reporting functionality on it and such. But there's nothing from the framework's perspective there that deals with this. It's all based on the individual use cases that customers have to build their own. The platform events enables you to do that in an asynchronous fashion without impacting the original transactions. But basically, from my experience, I haven't had to use custom objects yet. And then on top of it, basically, like I don't like to use them personally because of the downsides in production that they produce. But there's nothing that stops you from building out your own customization on top of the platform, like on top of the package. And that's fully backwards compatible or forwards compatible as well, because the platform events are always going to be published. So even new features and functionality, if you upgrade the package, this customization would continue to work.
So Johannes, you're saying that this log monitor that we're seeing here is a big object, and that those platform events are being published and saved as records on the big object, and that's why you're able to return such a large history?
Oh, almost. Yes,
okay,
and no
refine
at
that
the same
for me
time.
then.
Yes, happy to. So the dashboard handles both. Okay, so these connection modes, they have different sources of where they get the data from. New messages and historical and new messages, they are immediately hooked into the platform events, meaning that's why you see it popping up right away, right? If something is published, it notifies the dashboard, and the dashboard immediately renders the event. That's why it was so instant. As they were like the logs coming in, you saw the numbers going up, right? So that's platform events, and that's this general place where logs are being published to. Okay, and then there is the functionality via the custom setting, like there's the archive log level where you can say, in addition to the platform events, I want X amount of like all messages warning, error, or fatal in this case, based on the configuration here. If I change it to info, all info, warn, etc. events to be stored in the big object archive. Okay, so that's where they're going to be backed up, basically, to be persisted indefinitely. Platform events on the Salesforce platform are being kept in storage for 72 hours. So for 72 hours, like you can go in and click that historic connection mode, and you will always get your messages back. But then eventually they are disappearing, right? So if I had, like today is Thursday, if I had a message on Sunday, that message would not show up anymore based on the platform events. But if I stored it in the archive, then it would actually show up when I go in here. But I need to manage the archive myself, and I will eventually add more tools depending on what also the requests are to help the managing of data for the archive. Right now, you have to click this button in order to delete like 50,000 records in chunk. But I would be surprised if customers, if in production, even like get to the 1 million records very fast. That would be with this kind of like standard settings, it would be mean that either they have a lot of issues or that there's a configuration problem that they haven't set it up and log every info statement, which they shouldn't.
Okay, so to summarize, this is a combination of standard history for platform events that is 72 hours. So everybody, no matter what, can look up 72 hours of platform event history. And if you configure your custom metadata settings for either global or the particular user that we were looking at just a few minutes ago, to store a certain level, they get automatically archived, whether they're 72 hour within the 72-hour period or older, until you reach the max limit of the big object where they are archived with. Is that accurate?
100% spot on correct. Until they reach the limit of the archive, or you delete them, right? Manually.
Cool. Thank you for clarifying.
So fantastic. Thanks. Great questions. Jitendra asked, like, logs are stored in custom fields if type text or content version / notes object. So again, they're not really stored. You can store if you want them. Obviously, like the format of the data, this one here is a long text area field that maximizes the input, like of 132,000 characters. Everything else is like standard text fields around it from a conversion side of things. And obviously, if you have a log stack that for whatever reason is bigger than the maximum size of the log messages field, then it truncates from the oldest message first, right? So that you will always see the errors at the bottom, but then history is being cut off from the top. The framework makes sure that you don't run into any DML errors because of sizing.
Okay.
And then the last question she had, does it auto capture class method or line numbers? Well, that's really up to you. It doesn't do a stack trace for each of the log statements when it's being invoked and adds that as metadata. What you see here is the metadata that it automatically adds to each message, which is before the message is printed, we have always timestamps, log level, user context, and then the Salesforce request ID as well, which allows you to link the RFLIB logs back to Apex logs in case you're digging deep and working with the two log sources together.